Okay, they're messing with you on this one, right? The first problem actually has two parts to it. Find the sum of the first 100 natural numbers. So 1 plus 2 plus 3 plus dot 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 plus 100. This is a classic problem, by the way. It's kind of one of the stories that we tell about this, about the sequences and series. So clearly this time there are 100 terms. So the sum of these first 100 terms is going to be 100 over 2 multiplied by the first term plus the last term. So in other words, we get 50, which is 100 over 2, multiplied by 101, and so the answer is 50, 50. Think about how much time that would take if you literally were adding 1 plus 2 plus 3 plus dot dot dot. For the second part, it says, then find the sum of the first 50 positive odd integers. So that would be 1 plus 3 plus 5. So the first one is 2 minus 1. So the 50th one is going to be 100 minus 1. That's going to be 99. So this time we would be adding up the sum of these 50 numbers would be 50 over 2 multiplied by first term plus last term. So 50 over 2 is 25, and 1 plus 99 is 100. So this time we'd be getting 2500. So think about how you could use those problems in order to figure out the sum of the evens, perhaps. Can you figure out why it's a little bit different than 2500 and why half is showing up somewhere and a little bit more than half is in the other? Okay, going to this problem, the sum of the 250 terms that are satisfying here, right? So here it's going to be the sum of the first 250 terms. So that's going to be 250 over 2 multiplied by the first term, which is what you get when you stick in 1. 100 minus 1 is 99, plus the last term, which is what you get when you stick in 250, so that'll be negative 150. So we have 125, 250 over 2, multiplied by 99 plus negative 150, 99 minus 150, which is negative 51, and so the answer here would be that negative 51 multiplied by 125, looks like negative 6,375. Can you tell why that one got a little bit negative on us? Okay, now some applications, some word problems. How many seats are in an auditorium if the front row has 20 seats, and each row after the first has 4 additional seats, and there's a total of 30 rows. So the first row has 20, and we keep on adding on 4, so the 30th row will have first term plus n minus 1 multiplied by d. So the 30th row is going to have 20 plus 29 times 4, 136 seats. And so the sum of all the seats in the first 30 rows would be 30 over 2, first row plus last row. In other words, 15, 30 over 2, multiplied by 156. 15 times 156 yields 2,340. So this auditorium has 2,340 seats. Finally, the bottom row of a stack of toilet paper, I did this in honor of our homeboundness right now. The stack of toilet paper has 24 rolls in the bottom row, 24, and each row above has one less than the row below it. So it's kind of like stacking up like this, right? 2, 2, 3, 4, 1, 2, 3, something like that. So each row has one less than the row below, so that's going to be d equals 1. And the top row has 15 rolls in it altogether, so the a sub n is going to be 15. 15 is in that last row, the top row, which is equal to the first row, the bottom row, plus n minus 1 times that common difference. We'll have to use this in order to figure out how many rows there actually are. So subtract 24, then divide by negative 1, and then add 1. So it looks like there are 10 rows in this stack of papers. or a stack of toilet papers. So the sum of those 10 rows would be n over 2 multiplied by the first row plus the last row. So we're getting 5 multiplied by 24 plus 15, that's the 39. And 5 times 39 would be 200 minus 5, so that's a 195.